Hey, what's up, people? I've got three POE switches sitting on the bench, as you can see. Supposedly, all three of these are dead, but I don't think that's exactly accurate. These three were actually given to me by an uncle of mine that works doing like access control stuff. He said that these three switches were installed in racks and they were powered, but that they were never actually put to use, that they just kind of sat there. And supposedly, like, eventually they just, I don't know, I guess they sort of like crapped out or something. So I brought them and I tried powering them up, and it doesn't appear that all three of them are totally dead. So I've got the first one plugged into power. If we turn it on, you can see that the lights kind of flash there. It appears to be doing some sort of like power on self-testing. Some of the LEDs turn on and flash. And we're going to see these flash here in a sec. There. So, and then the power LED comes on, and it appears that it's like ready to go, and it's all gone through its like self-test stuff, and it looks like it's fine. So I don't know, this one might be okay. The second one, if we turn that one on, it looks like it's trying to do its power on self-testing. We see that the LEDs also come on. The ones over here also came on, but they don't go out. And the power one there stays on the entire time. And it looks like it just kind of locks up in the middle of doing its power on self-test. So judging by what this one did, I don't think this one is normal. And from now on, it'll just kind of sit there like this. And the third one, well, if we turn that one on, it makes a little bit of a whining sound when you first hit the switch. But it just sits there kind of dead. Like there's nothing going on. The fans don't power up. So out of the three, this one appears to be the deadest. And actually, this one doesn't appear to be dead at all. And then this one's just kind of in limbo. So since this one doesn't appear to be dead, and this one's completely dead, and this one's in limbo, let's go with the deadest one first. We'll see if there's something like easy to deal with, or if it's just something like not very serious that's wrong with this one. Because if this one's locking up in the middle of doing a power on self-test, that might be more of a firmware or a software issue, and that might be a little difficult to deal with. I don't know for sure. So let's open this one up first. Oops, I did it again. All right, that's the last screw. Okay, so let's remove the cover. I think all the screws should release it. Does it slide back? How does this come off? Okay, so I removed 4 more screws from the bottom of the faceplate. That appears to be releasing the faceplate, so that comes off. And now the cover comes off. So there's our power supply. It looks like it's just providing 1 voltage to the actual POE switch. I'm going to guess that this is probably going to be about 56 volts. All the lower voltage regulation stuff is going to be like in this area. No capacitors looked popped or leaky. Everything there seems to be okay. On the power supply, those capacitors look okay. And there's a much closer view of that, so you can see that none of these capacitors look leaky. There's a smaller one there that also doesn't look leaky. That's probably going to be a voltage adjustment. These 2 bulk caps look fine, and obviously this fuse is going to be okay if when I hit the switch, we hear a whine. So let's plug it in and check voltage at this output. We'll see if the power supply is even doing anything at all. If there's nothing coming out of this connector, then we're going to have to assume that the problem is going to be on the power supply itself. Okay, we've got the voltage readout on the screen. We've got a cord plugged in, and the switch is currently in the off position. So I'm going to hit the switch. There, I just heard the whine. Let's see what we have at this output. We have 52 volts, so that seems to be fine. So our issue is probably going to be in this area then. And I just realized that the specs of the power supply are actually on this label on the side where this heatsink is. So that's kind of handy. I don't see any fuses in this area unless there's some underneath, but it actually looks like all these rails, or the 2 rails, look like they just kind of come straight down. So I don't know that there would be any fuses anyway. This device is going to be a switching regulator, most likely. It's got one of these. These are like little heatsink pads. Well, how about we just remove the board and see what's on the underside of the board? Maybe there's like more of a visual cue underneath that. will give us a hint as to what's going on. Okay, so there were 2 screws and then a bunch of taped down standoffs with small clips that you have to push in to release it. And that's the underside. No visual physical damage that I can see. Now, one thing I noticed when I was removing the board was that this area was kind of warm. So these are also probably going to be regulators, judging by the rest of the stuff on there. There's a few cutoffs, or these are resettable fuses. Guess we can check those and see if they both have continuity. But in order to see what these are supposed to be, we're going to have to remove those pads. Ooh, I guess I spoke too soon about nothing looking burnt. There is a one... That was dusty. There's a 1 ohm resistor in this spot that goes to this regulator. That looks like it's got some, like a burn mark. So let's measure that and see what it measures. I would say that that's open. But why did it open? On the board, we can see that these pins are labeled 48 volts. So that's going to be the high voltage going into this switching regulator. Let's see if the output is shorted by touching one side of the probe to that and then the other side to ground. That is shorted. Okay, so it's possible that maybe this regulator is dead. And we don't have a short in the pins coming in, obviously, since the power supply was producing 52 volts. So it looks like this regulator might be dead. Let's unmask it and see what it is. It's a tech code TD15001HSADJ. Okay, so this is a switching regulator, but it's also available in fixed and adjustable versions. And the one that we have is an adjustable regulator. It's switching this inductor, and the output appears to be going to the fan. So it's going to be a 12-volt regulation in this area, most likely. So this is a high-voltage input switching regulator. If we remove it from the board and inject 12 volts, I guess I would have to do it to this side. Maybe the unit will come to life, and we can actually check and see. Well, first of all, we should remove it, see if the device itself is actually shorted. And if it is this regulator that's shorted, then I can use my bench power supply and inject 12 volts and see if the switch comes to life. If that's the case, then this regulator would need to be replaced, and this resistor as well, because that's burnt. So yeah, let's see what happens. Man, that took way too much heat, but finally got it off. Okay, let's see. Do we still have a short? So there to there. And nope, short is gone. So on this regulator, pin number 2 is the output, which is what would have been shorted, and the center pin, that is ground. Oh, wait a second. VN is the one that would be shorted, so by itself, it's saying 111K. Oh, so input to output is shorted. Well, that's not a good sign, because then that means that it probably went straight from input to output with 52 volts. And if that's the case, that probably could have done some serious damage to the rest of the circuitry. But it is kind of weird how we were getting a short from ground. Checking it on its own, we're not really getting that. So I just realized if I check the continuity from ground to that resistor, I'm not going to get anything, because that resistor went straight into the regulator IC. Where I should have checked is on the output. And if I check the output, which would be pin number 2, and it just goes straight into this diode, so I can just push on that, we still have a short. So something else is dead on the board, and I don't see anything. Yeah, I haven't seen anything visibly damaged. So I think what I might be able to do is maybe try injecting a low voltage into where the regulator would have been doing its output, and seeing if something on the board heats up. I could use the thermal camera for that, and maybe that'll point us in the right direction as to what else to check. Because, yeah, if the 52 volts hit the 12 volt section, that could have done some a good amount of damage to other stuff on the board. Okay, I soldered 2 wires, one that goes to the ground, which is also the tab of the regulator, and then the output of the regulator, which would go to that diode and this inductor. So I'm going to connect this to my power supply, and right now I only have it set to 2 volt output, but I'm going to really limit the current, and if we get a kind of a baseline look at the board with the thermal camera, we can see that everything looks pretty cold. This area looks warm, but that's just where I soldered the wires, so that's going to be, yeah, obviously warmer. But nothing else looks warm. This is like the shielding that's kind of reflective, so we can see that it's kind of lights up there, but also these heat sinks. But nothing else is warm at the moment because there's no power being applied. So I'm going to plug in the power supply, or the 2 banana jacks to the power supply. And it's obviously shorted, and my power supply is not outputting anything. So I'm going to start increasing the current, and we'll see if anything warms up on the board. And at the moment, we still got nothing because I have nothing on the power supply. So I'm going to increase it to, let's see, let's do 100 milliamps. Okay, so at 100 milliamps, it's currently outputting about 0.1 volts. And no, nothing is visibly warm. So I'm going to increase the current to maybe like half of an amp. Okay, I had it go all the way up to 2 amps, and then it's finally drawing, or it's outputting about 0.6 volts. And check out what's getting warm. That diode, the one that we just soldered to. Nothing else on the board appears to be warming up. So we might have gotten off lucky. Let's remove that diode and see if the short completely goes away. And I'm going to try to remove the diode using the spicy chopsticks. Already put some flux on it. All right, there we go. All right, let's see. Is the short gone? So ground and output. No more short. And that's just changing probably because we're charging some capacitors. So, okay. All right, so I reattached the wire that I'm going to feed 12 volts into. That's going directly to the pad where the diode used to be. So that's going to be externally powered from my other power supply. And I'm going to provide the other 52 volts with the built-in power supply. So right now the switch is off, and I don't have the banana plug to the power supply plugged in just yet. I'm going to try to turn it on and plug this in at the exact same time. And we'll see if we're able to pull an evanescence and bring this thing back to life. So here we go. I got my finger on the switch. Got the banana plug at the ready. And just doing one more visual inspection just to double check that I didn't miss anything. I think we are good to go. All right. I got the positive on the, or the negative on the negative, and positive. We're good. Okay. Here we go. 3, 2, 1. Hey, check it out. The LEDs just came on, and it looks like it's going through its self-test procedure. This LED, hey! It came back to life. Awesome. There's a little LED on the board that's lit up, so it looks like that diode shorting out possibly saved the rest of the circuitry. Of course, I'm still going to have to, plug this into a PC and see if we are able to connect to it. But it seems to have passed its power on self-test, so that's a promising sign. And I'm going to try to connect to this in a sec, but I'm going to just go through the reset procedure, which requires pushing the reset button for about 10 seconds, it said in the manual. And then after that, I can get I'll get a laptop and I'll plug it into the port, and I'll see if I can get into it's got like a little built-in GUI, I believe. So let's see what happens if we push this for 10 seconds. Oh, this LED in the back is like frantically flashing, I just noticed. Nothing else in the front appears to be doing anything. Oh, actually, I just stopped flashing even though I'm still holding the button down. So maybe that's completely reset. It doesn't seem to be doing anything else in the front. Okay, I'll leave it at that. Well, sweet. Check it out. So I got a cable plugged into it. I got it hooked up to this laptop, and I was able to log in with the default settings that are in the manual. So the default login should be admin. Would I put admin? Admin. There we go. Admin and admin. So we should be able to log into it, and there it is. So sweet. It appears that this is working. All right. So this unit is just going to need a new regulator and a replacement diode. Well, I guess we should actually test and see if this thing can power anything. So, I mean, I can't fully load it, but I have a 1IP camera that I can at least hook up to it at the moment. And we can't see the output from this because it requires a setup with some software. But I've got a cable that I can plug into it. And this is actually a Cat 6 cable. Look how thin that is. That's crazy. I've never seen one that thin before. But let's plug this in, and we'll see if the camera comes to life. And there we go. Lights are flashing. And I do have a status LED in the front, so it looks like it did connect. And sure enough, on the console, there it is. So it appears that it at least works to that extent. All right, and I also just tried it out on a few other like random ports just to see, and it looks like every one I've tried so far appears to work. So I think it's going to be fine once those components are replaced. Just to do a comparison, I decided to open up the switch that appeared to be fully functional. I plugged in the laptop to it, and I'm able to connect to it just fine. I can see the console. I also plugged in the camera to it, and it's powering it. It seems to be totally fine. And if we check the voltage in that area, try to be careful because now we are powering this with 52 volts. If we check it at the output, we for sure are getting 12.2. It's kind of fluctuating there a little bit, almost 12.3. Everything appears to be working correctly. But let's check some of the temperatures in this side of the board. Now, just by doing a sort of a touch test, if I check these two devices that are like soldered right there on the board, they're kind of warm. These two other ICs, they're noticeably warm. This switching regulator, yeah, it's definitely warm. But check out this coil. All right, ready? Here we go. It's over 100 degrees C. That is insane. And I mean, this is going to be in an enclosed area because, it would have the cover on and everything. And then plus, if it's in like a server rack or something with everything else running, I have a feeling that that's probably why the other regulator died. And if just left like this one's probably going to die at some point also. And also look at how close these two electrolytics are to that coil. That's crazy. So I think something would have to be done in order to get this to be a little bit more reliable, whether it's like cooling this area better or completely replacing this switching section with something different. So I think maybe like a separate power supply would have been good to have, or like a separate power supply section where it also outputs like a lower voltage to power up some of the lower voltage stuff. I don't know. But yeah, I have a feeling that this design here is the reason why maybe some of these go bad. And last but not least, this is the one that powered on, but seems to lock up when it's doing its power on self-test. As we can see, all the LEDs on this one are on. And one thing I did notice when I first flipped the switch on these is that this one appears to have louder fans than the other two, almost like they rev up a little higher. So let's check the voltage coming out of that regulator and see what we have. 13 volts. And it seems to be fluctuating, almost like it's going down a bit. I actually did check it right as soon as I turned it on, and it was actually up as high as like 14 volts. So I'm going to turn it off for a bit, and then I'll power it back up and see what sort of voltage is at the output. Okay, I've let this cool down for a bit, and I've attached the probes. Let's power it on and see what sort of voltage it starts off with. There we go. 13.8, 13, yeah, so it's very close to almost 14 volts. And so I'm wondering if it's failing its power on self-test because it wants to make sure that all the voltages are at the right levels. And if all of that passes, then it continues with its boot process. So I think what we can try to do in this one is, I really don't want to remove the entire regulator because that was kind of a hassle on the other one. So maybe if I just remove either that resistor or lift up the power input pin on the regulator and just inject 12 volts directly into the diode, or where the diode is, as I did on the other one, we can try to power it back up and see if it completes its power on self test. So it could be that it's not a software issue at all or a firmware issue, and that it's just another voltage issue with this one. All right, so I lifted the first leg on the regulator, so that's no longer going directly to the 52 volts through that 1 ohm resistor. And I've soldered a wire directly to the diode, and that's going to go to my bench power supply. And I depinned the connector coming from the power supply. That way I can just inject the ground or connect the ground from my bench power supply directly into the board. For this use, or for this test, it's not going to matter that I don't have all of them hooked up because they're all in parallel anyway, and we're not pulling like a lot of power from the ports. So we just want to see if it boots up when it gets a more regulated 12 volts. So I'm going to put my multimeter probe on the output of the coil, and this should work. Injecting 12 volts into there with the regulator still on the board, it shouldn't do anything. So I'm not going to be able to do this with one hand. So let's see. I'll just put the probe into the connector of one of the fans, because that's connected directly to 12 volts. All right, here we go. Now I got two hands I can use. So I'm going to do the same thing I did on the first one, where I flipped the switch and I plugged it in at the same time. Here we go. 3, 2, 1. All right. So LEDs in the front are flashing, and it stopped at the same place. So yeah, that didn't solve anything. It says 11.9 volts going into it. So it appears that something else is wrong. Now, I didn't check any of the other switches to see what some of the voltages were supposed to be. I guess I could use the one that actually powers up and everything to check. But if I check a voltage on the opposite side of this coil, which appears to go through this switching section, we have 0.88, almost 0.9 volts. I don't know if that's the correct voltage. The capacitor that's on the output is a 16 volt capacitor, and that's at 470 microfarads. So if this was supposed to be like a really low voltage switching section, that capacitor seems like it's a little bit over spec voltage wise. Usually, it'll be something like a lot lower. Over in this section, both of these resettable fuses, they both measure about 52 volts. So these are probably, coming straight from the input. So that seems fine, or at least I wouldn't think that that's a problem. I guess we could check it on the other one. So what else can we look at? Let's see. Well, there's a large capacitor on the board on this side. Let's see what voltage is on that. 0.84. So this is probably part of that section. We got about 3.3 over. I should scoot this over on this side of the board. 3.3. Yeah, that sounds about like a normal voltage. Got 0.88 again at that point. Okay, so I'm going to move this one out of the way. I'm going to plug in the known good one, and we'll see what kind of voltage it's outputting at that section, and see if this is the right voltage. Okay, I've got the known working one back on, and I could have sworn that I checked the voltage coming out of this voltage regulator section, and now it's the 13 volts. So not entirely sure what's going on there, but let's see what this section is then. I haven't checked it yet. So here we go. Let's plug that in there. Let's put that in there. So 2.156. Okay, so on the other one, this voltage is definitely not what it should be, apparently. So let's see, where was that other capacitor I checked? I think it was somewhere over in this. It was this side, I think. There it is. Okay, so it looks like I'm losing contact there, but so yeah, it looks like on that other switch we are missing a voltage, and yeah, it appears it's got something to do with that section. Yeah, I think when I checked the voltage on this one the first time around, I had actually had it sitting here for a while, and it appears that after a while the voltage just drops because it's still dropping. So maybe that's why when I checked it was closer to 12 volts. All right, so let's bring the other one back in and see if we can figure out what's going on in this section. Well, this was kind of easy to find. So check this out. This is the one that works, the only good one of the bunch. And if I check resistance between what I'm, these are probably MOSFETs. I haven't looked up, or I haven't even looked at the numbers yet. But I'm assuming this is going to be the gate, and this is going to be the source. So if I check resistance between those 2 points, as you can see, we have about, I'm losing contact there, but it's a very high resistance, so almost 6 megohms. If I check the one that's not working, and I put in the positive on the gate, and this one on what would be the source, we have about 1 ohm. So something definitely wrong there. I don't know if it's this actual device that's bad or if it's something else down the line. What I could do is lift up the leg on the corner and do the measurement again and see if it's on the device itself or if it's on the board. Unfortunately, I wasn't recording when this happened, but I actually had lifted the leg up after I heated it up with the soldering iron, and the leg was still attached, but then when I went to go clean it with the soldering braid, just to make sure that there wasn't any solder between the leg and the pad, the leg actually came out of the package. And yeah, it turns out that these are MOSFETs. This is an SM3119 MOSFET, and well, unfortunately, it lost its leg, so it would have to get replaced regardless. But now we can check between that point and see if we still have a 1 ohm resistance. If we don't, then we can pretty much assume that it definitely was that MOSFET that was shorted. So let's see what we have. We can see the measurement there on the upper right. I'm going to hook this up the exact same way that I had it, where I had the negative probe on that side, and I put the positive probe there. And nope, there's still 1 ohm of resistance, so something is still wrong. And since this is a MOSFET and that's the gate, then this pin is going to go to a controller of sorts. So let's see if we can figure out where that is. So we've got 2 vias that go to the opposite side of the board, and that turns out to be these. So this trace goes down this way, and that's actually a pretty thick trace for just being the gate drive. And so there's a 0 ohm resistor. It goes to another via on the opposite side. And not really any surprises. It goes to this IC that's located like directly behind it. So it would be that pin. And that is an APW7120. And there we go. That happens to be a 5 to 12 volt supply voltage 8-pin synchronous buck PWM controller. So that makes sense. And if we look at the pin that the MOSFET's connected to, that's the lower gate. So it looks like maybe this part is bad. So on this board, pin 5 of this IC is the VCC. So if we check continuity between that pin and the 12 volt output of the 12 volt regulator, the switching, we see that we got about 2.37 ohms. So it looks like the 12 volt section is what's feeding this lower voltage section. And both of these MOSFETs are the same. They're both SM3119s. So let's remove this MOSFET off the board and see, or not the MOSFET, this switching controller off the board and see if this short goes away. And I don't want to use hot air to remove this just because there's this electrolytic like right next to it. So I'm just going to use some low temperature melt solder. Some people call this low melt solder, but I don't really like that term because it just sounds like it's going to melt a little bit. It's just going to melt like a slight amount, but I'm going to put some of that on that side, put a little bit more on this side. And as we can see, it's already looking pretty loose. So there we go. Take it right off. Make sure that none of these are shorting. All right, that looks good. Okay, and there we go. So we definitely should not have a short between these 2 points anymore. And, well, I had it like this, but if I could get that right. There we go. So, yeah, because it all goes through that IC. And so let's check the pins on this IC. Let's connect one probe to ground, or its ground point, and the other one to that output. All right, I got 1 and I got 2. There we go. So, yep, this IC is shorted. Okay, so I removed both of the MOSFETs, and including the high side MOSFET, and I soldered a wire that goes directly into this coil. And that's where we're going to inject 2.2 volts, because I think that's probably what it's supposed to be, or it should be at least close enough. Once again, we're using the same arrangement. I got the ground going into that connector, and then the positive, and I haven't plugged it into the power supply yet, but I got the power supply set to 2.2 volts. And once we flip it on, we'll see if if it finishes doing its power on self-test stuff, and hopefully that'll work. There don't seem to be any shorts to ground on the output of this, so I think that it should be okay. So here we go. We're going to do it in 3, 2, 1. Oh, actually, before I do, sorry, let's change this. Let's check the voltages. All right, now just keep this to the side. We'll check it once I got everything plugged in. Okay, here we go. 3, 2, 1. And hey, it booted. The LED's on. All the other ones turned off. This one should flash here in a sec. Or did it already do it and I didn't see it? I am not sure. Oh, I just realized the... okay, let's turn this off. The voltage dropped down to a 1.5 volts because it's pulling more than I allowed the current to be at. So, okay, so 1 amp was not enough. I'm going to have to increase the amperage. Let's just go ahead and go up to... Let's do 3. Maybe that'll be good enough. Okay, here we go. In 3, 2... Oh, I thought I felt something weird. Okay, never mind. So here we go. 3, 2, 1. And LEDs are blinking. Okay, it finished that one. That's right. Okay, so it got past that one. This one is on. Not yet. Okay, there we go. That one's on. There we go. And now it's pulling at about 1 point. Okay, it dropped down to 0.8 amps. So it looks like it takes a lot of current on that particular rail. So let's see. We should have about, yeah. So we're measuring about 2.1384 volts at that, at the other side of that coil. So yeah, definitely a bit of a high current rail when it first boots up, but it appears that that worked. So I'm going to hold down the reset button for 10 seconds. Okay. And that should have reset the switch. Let's just pull that out of there before I break something. And none of this is going to short. So I'm going to plug in my laptop again. Okay, these LEDs are blinking, so that means I've got a connection. Let's see if I can log into it. Okay, so it came up. It says, because all the settings are the same for all the switches once it's reset. So let's see if we can log into it. There it is. So that's definitely working. Okay, so yeah, it seems to be working. So, man, a bunch of voltage regulation issues with these things. Let's plug in the camera again and see if it comes up. I'm just going to pick a random port. Let's pick this one. And LED came on. Camera, okay, LEDs come on, so it should go through its boot process. It's powered up. And yeah, there it is, showing up on the console. And once again, this coil is running crazy hot. Just the amount of time that it's been on, it's almost at. So yeah, that's probably just going to keep increasing. 78. All right, so what's the verdict? Well, it looks like we can get all 3 of them to work well again. I mean, this is the one that appears to be working totally fine. And one thing I hadn't noticed until just right before I started recording this is that on this one, the fans really don't seem to have any noticeable dust on them, where on the other 2 that were completely dead, well, this is the one that was missing the 2.2 volts. That does have dust in the fans, and so does the one that was completely dead. So maybe this one just was never actually put into operation, and it was just sitting there. But I would still want to at least deal with the high temperatures of the switching regulator section, because, yeah, those temperatures are kind of ridiculous, and I have a feeling that's probably why these other 2 failed. So for the time being, I think we're just going to cut this video off for now. I know that we can at least get these 2 to work if I can find the replacement parts, which I got to figure out where I can do that, or where I can get the parts from. And also, I got to figure out some solution to the high temperatures issue with that all 3 of them are going to have. Because if I just leave it as is, then eventually this one's probably going to end up with the same fate as one of these 2, and one of the voltage regulators is going to die. So yeah, I'll try to figure that out. I'll see if I can find the parts that I'm going to need. and then we'll come back at a later point in time, and we'll try to finish all 3 of them up and see what I come up with, because I don't exactly know what to do about that high temperature issue yet. But yeah, we'll just leave it there. Thank you all for watching once again, and I will see you guys around the bench.